Hi, hello, I am Muthulakshmi, Assistant Professor of Computer Applications, and in this video lesson we are going to see TCP/IP reference model in computer networks. Communication plays an important role in sending messages from system to system. The protocols are the set of rules that makes the communication easy to send the data from one computer to another. These are the objectives of the TCP/IP reference model. In this video lesson, we see TCP/IP reference model, comparison between TCP/IP and OSI reference model, and what are the problems that are occur when we move from OSI model to other protocols. Then what are the critics in TCP/IP reference model. TCP/IP reference model. What is TCP/IP reference model? TCP/IP reference model was developed prior to the OSI model. The TCP/IP model is next. It's not exactly similar to the OSI model. The TCP/IP model consists of 5 layers. They are application layer, transport layer, network layer, data link layer and physical layer. The first 4 layers provides physical standards, the network interface, networking and the transport functions that correspond to the first 4 layers of the OSI model, and these 4 layers are represented in TCP/IP model by a single layer called application layer. The TCP/IP is a hierarchical protocol made up of interactive modules, and each of them provides a specific functionality. The hierarchical means each upper layer protocol is supported 2 or more lower level protocols. And this is the difference between OSI reference model and TCP/IP model. In the OSI reference model consists of 7 layers, while the TCP model consists of 4 layers. But in later version, it is converted into 5 layers. That is, the network access layers is divided into physical layer and data link layer. These are the applications. The center ones are the protocols, that is PPP, frame relay, Ethernet, IPv4, IPv6, TCP, UDP, HTTP, TNS. These are the set of protocols that provide services for the each layers. Functions of TCP/IP layers. The upper layer is application layer. It consists of SMTP, FTP, Telnet, DNS, SNMP, FAS and TFFP protocols and RPC protocol. The transport layer consists of TCP and UDP protocol. Network. The network layer consists of ICMP, IGMP, IP, ARP and RARP protocol. The last lowermost layer is physical layer and data link layer. They are grouped under network access layer. The first and lowermost layer is network access layer. The network layer is the lowest layer of the TCP/IP model. It is the combination of physical layer and data link layer defined in the OSI reference model. It defines how the data should be sent physically through the network. This layer is mainly responsible for transmission of data between 2 devices on the same network. The function carried out by this layer are encapsulating the IP datagram into frames and transmitted by the network, and mapping of IP address into the physical address. The protocol used by these layers are Ethernet, token ring, FDDI, X.25 frame delay. Next one is internet layer. The internet layer is the second layer of the TCP/IP model. An internet layer is also known as network layer. The main responsibility of internet layer is to send packets from any network, and they arrive at the destination irrespective of the route they take. The following are the protocol used in this layer. First one is IP. IP means internet protocol used in this layer, and its most significant part of the entire TCP/IP suite. IP addressing. And these are the responsibilities of this TCP/IP protocol. First one is IP addressing. It implements the logical host addressing known as IP address. The IP address is used by the internet and higher layers to identify the device and to provide inter-network routing. Next one responsibility is host to host communication. It determines the path through which the data is to be transmitted. Data encapsulation and formatting. An IP protocol accepts the data from transport layer protocol. An IP protocol ensures that the data is sent and received securely. It encapsulates the data into messages known as IP datagram. Next responsibility is it sends the data and split it into fragmentation and reassembly. The limit is imposed on the size of IP datagram by the data link protocol known as maximum transmission unit. It's called MTU. If the size of IP datagram is greater than MTU, then the IP protocol split the datagram into smaller units so that they can travel over the local network. Fragmentation can be done by the sender or intermediate router. At the receiver side, all the fragments are reassembled to form a original message. Next, routing. When IP datagram is sent over the same local network such as LAN, MAN, WAN, it is known as direct delivery. When the source and the destination on the distinct network, then the IP datagram is sent indirectly. This can be accomplished by routing the IP datagram through the various devices such as routers. ARP protocol. It stands for Address Resolution Protocol. ARP is a network layer protocol which can be used to find physical address from the IP address. Two terms are mainly associated with ARP protocol. First one is ARP request. When the sender wants to know the physical address of the device, it broadcasts ARP request to the network. ARP reply, each device attached to the network will accept the ARP request and process the request, but only recipient recognize IP address and send back its physical address in the form of ARP reply. The recipient adds the physical address both to its cache memory and to the datagram header. ICMP protocol. It stands for Internet Control Message Protocol. It is the mechanism used by the host or router to send notification regarding datagram problems back to the sender. A datagram travels from router to router until it reaches its destination. If a router is unable to route the data because of some unusual conditions such as disabled links, a device is on the fire or network congestion, then ICMP protocol is used to inform the sender that the datagram is unavailable. ICMP protocol uses two terms, ICMP test and ICMP reply. ICMP test means whether the destination is reachable or not. Reply means to check whether the destination device is responding or not. The core responsibility of ICMP protocol is to report the problem, not correct them. Replay what is the problem, not correct them. The responsibility of correction lies with the center. ICMP can send messages only to the source but not to the intermediate router because IP datagram carries the address of the source and the destination but not of the router that it is passed to. Next layer is transport layer. It is responsible for reliability, flow control and correction of data which is being sent over the network. There are two protocols in transport layer. They are user datagram protocol and transmission control protocol. First one we see user datagram protocol. It provides connectionless service and end-to-end delivery of transmission. It is unreliable protocol as it discovers the errors but not specify the errors. User datagram protocol discovers errors and ICMP protocol reports the errors to the sender that the user datagram has damaged. UDP consists of following feeds. First one, source port address. It contains the address of the source, and then destination address. The destination address is the address of application program that receives the message. The total length defines the total number of bytes of the user datagram in bytes. Checksum is a 16-bit field used in error detection. UDP does not specify which packet is lost, but UDP contains only a checksum. It does not contain any ID of data segment. This is the format of UDP. Variable contains header and data, and the header contains source port address in 16 bits and destination port in 16 bits. The total length is 16 bits and the checksum in 16 bits. Next we see TCP IP, that is Transmission Control Protocol. It provides a full transport layer service to the application. It creates a virtual circuit between the sender and receiver, and it active for a duration of transmission. TCP is a reliable protocol as it detects the error and retransmit the damaged frames. Therefore, it ensures all the segment must be received and acknowledged before the transmission is considered to be completed and a virtual circuit is discarded. At the sending end, TCP divides the whole message into smaller unit known as segment, and each segment contains a sequence number which is required for recording the frames to original message. At the end of the receiving end, TCP collects all the segments and records them based on the sequence number. And the uppermost layer is application layer, and the application layer it is the most important layer in TCP IP because it only communicates with the application programs. It handling a high level protocol issues of representation. It allows the user to interact with the application. When one application layer protocol wants to communicate with the other application, it forwards its data to the transport layer. There is a ambiguity occurs in the application layers. Every application cannot be placed inside the application layer except those who interact with the communication system. For example, text editor cannot be considered as application layer, while web browser using HTTP protocol to interact with the network, where HTTP protocol is an application layer protocol. The following are the main protocol used in application layer. They are HTTP, SNMP, SMTP, DNS, Telnet and FTP. First one is HTTP. It stands for Hypertext Transfer Protocol. It allows us to access data over the World Wide Web. That HTTP means hypertext, so it includes plain text, audio and video. Then next SNMP, it stands for Simple Network Management Protocol. It is a framework used for managing the device on the internet by using the TCP IP protocol suite. SMTP, it stands for Simple Mail Transfer Protocol. The TCP IP protocol supports email on a Simple Mail Transfer Protocol. DNS is a domain name system, an IP address used to identify the connection of the host to the internet uniquely. It helps to find the address of the system. Telnet, it is an abbreviation for terminal network. It establishes a connection between local computer and the remote computer in such a way that the local terminal appears to be terminal at the same remote system. FTP is a file transfer protocol. It is a standard internet protocol used for transmitting files from one computer to another. Comparing USA and TCP IP model, the concept are same. The services provided by TCP IP models are most equal to OSI reference model, but TCP IP model is designed before to the OSI reference model. So OSI reference model has a clear set of protocols in each and every layers, and then it contains interfaces between one layer to another, then protocols. A critic of OSI reference model and protocol. Why OSI not take over the world? Because it contains 7 layers, and timing is bad timing, bad technology, bad implementation and bad policies. Bad timing means if apocalypse the 2 elephants, suppose we have 7 layers in OSI reference model, so it not clearly specify the interfaces between one layer to another. So that timing is not interact with the other layers. Researchers and the standards and $1 billion investment, so it's not best compared to TCP IP model. The critic of TCP IP reference model, the problems are service interface protocols are not distinguished, not a general model, host to network layer, not really a layer, no mention of physical and data link layers, minor protocols deeply enriched and hard to replaced. So we form a hybrid model. It contains both benefits of OSI reference model and TCP IP reference model, and now we use TCP IP reference model, which contain these following 5 layers: physical layer, data link layer, network layer, transport layer and application layer. These are the some examples of network. We use these protocols in internet connection oriented networks like X.25, frame delay and ATM, Ethernet and wireless LAN 802.13. From this we conclude that the central aim of TCP IP was enable the sending of data from one application to the another on a single computer. Some of these goals are hardware implementation, like a protocol suite that can be used on Mac PC, mainframe or any other computer. The software independent, the protocol suite that could be used by different software vendors and its applications. So TCP IP reference model is used to form an internet, used to send protocols, used to send data from internet to the mobile to mobile or any other devices using these protocols. From this we know that TCP IP is simplest protocol when compared to the OSI reference model. Thanks for watching.